Oxygen was discovered. It was named the acid producer by Lavoisier, and that's because it combined with non-metals to dissolve in water to produce acid. So that means some non-metallic oxides of oxygen, when dissolved in water, they produce acid, and that's what we know as acid anhydrides. Today we are going to be talking about the nature of oxygen, and my name is Antonio. So let's get to work. Now, oxygen is a gas that is consisting of the 20% of the combustible part of the air. That's 20% of the combustible part of the air is oxygen. And there are different ways of preparing oxygen. One popular way of preparing oxygen is in the laboratory is the decomposition of potassium trioxychlorate. For example, whenever you have KClO3, O3, so this will decompose to form potassium chloride, KCl, and to also form oxygen, 3 moles of oxygen, O2. That means this solid breaks down into potassium chloride solid, then to form oxygen gas, 3 moles of oxygen gas, 2 moles of potassium, 2 moles of this. So this is one way of preparing oxygen, and the catalyst used here is manganese dioxide, MnO2. So that's catalyst, manganese dioxide. And this setup is not the only way of preparing oxygen in the laboratory. You can also use the composition of hydrogen peroxide, where you have H2O2, which is hydrogen peroxide. It's broken down to form water, H2O, and oxygen. This is another way of preparing oxygen. Can balance it this way. So then we have 2, yes. So 2 moles of hydrogen peroxide will dissociate to form 2 moles of water and then 1 mole of oxygen. That's another way of preparing oxygen. Yeah. So now, outside preparation of oxygen, there are different properties of oxygen. Let's talk about those. And before I talk about properties, let's talk about the industrial preparation of oxygen. And industrial preparation of oxygen doesn't involve much processes. You just make use of liquefied air. So basically, you make use of air, but you liquefy the air and then you extract the oxygen. Now, because nitrogen and oxygen have what's it called? They have boiling points which are close together. So most of the time, it often involves fractional distillation. So they make use of fractional distillation of liquefied air to extract oxygen in industrial preparation. Then we have different properties of oxygen. Oxygen is one of the few gases that will rekindle a glowing splint, which is placed in it. Aside that, we also have nitrogen. That's the nitrogen oxide is also another gas we can also rekindle a glowing splint. But you can differentiate it from oxygen in that oxygen does not have any smell, but the nitrogen oxide also has a smell. And another way you can differentiate it from other gases is that oxygen, when it reacts with nitrogen monoxide, it produces a brown gas, which is nitrogen dioxide. That is another way of defining oxygen. And oxygen is one of the principal reactive gases, because oxygen is basically the let's call it like the key of life, because every organism reacts with oxygen. Our respiration, most systems, our respiratory system, digestive system, and so on and so forth, we make use of oxygen. So if I want to start talking about the properties of oxygen, it will take a long time. So let's just give a summary of that. Oxygen reacts with metals. Yes, oxygen reacts with metals like phosphorus to form phosphorus 5 oxide, and even non-metals. So it reacts with non-metals like phosphorus 5 oxide to give react with phosphorus 5 to give phosphorus 5 oxide. It reacts with sulfur to give sulfur dioxide, and so on and so forth. Those are the examples of oxygen's reaction with metals. And then we have let's talk about the classification of oxide. There are different types of oxides. They are all called normal oxide. Examples of normal oxides are oxides that do not have alright, let's call them oxides that are neutral. Yes, neutral oxide. Example of neutral oxide is carbon monoxide. Carbon monoxide is a neutral oxide. So in that case, carbon monoxide does not react with water to form an acid. But acidic oxides are oxides that dissolve in water to form acid. An example of this is carbon dioxide, CO2, sulfur dioxide, SO2, and so on, SO3, sulfur trioxide, and so on and so forth. So these gases, they react with water to form acid. So that's what's called an acidic oxide. And then when a gas reacts with water to form a base, it's called a basic oxide. Then when a gas reacts with water or reacts with other elements or compounds to form both acids or bases, it's called an amphoteric oxide. Example of this is aluminium oxide, zinc oxide, and so on and so forth. So moving on, those are the three major types of oxide. Then we have the uses of oxygen. Oxygen is used in three major ways. For example, oxygen is used in for breathing aid. When you have people in hospital, they make use of this oxygen for breathing aid. Oxygen is mixed with other gases and then given to them for them to perform the normal respiratory process. And then oxygen is also used for making steel and the extraction of elements. For example, whenever you have zinc sulfide, when you react it with zinc sulfide with oxygen, you produce zinc oxide. So and then that zinc oxide is easier to extract zinc from zinc oxide. And then lastly, we also make use of oxygen in welding, just like acetylene flames, where you make use of oxygen and acetylene together. That combines to produce a very high temperature, which burns and then makes the welding possible. So thank you for watching.